Good morning, parents, teachers, and students. Welcome back to Valenzuela Facebook Live in Mathematics 9. Are you excited for our fun learning session? Come on, let us learn and have some fun, and allow me to guide you in learning the different concepts and skills in Mathematics 9. Before we begin, make sure you have a notebook and a pen for taking down notes. You may also use the chat box to key in your answers to the questions that I will be giving throughout the discussion. Are you ready? Great! Let's start! Our lesson for today is about law of signs. At the end of the discussion, you must be able to illustrate law of signs and find missing parts of a triangle using law of signs. Let us have an activity entitled Mathinique. In this, you are going to choose the emoji of the correct answer. You will be given 10 seconds to key in your answer. Let us begin. Number 1. What is the missing length of a side of the right triangle given the length of two other sides? Refer to the given figure. Click like react if your answer is 8 meters. Heart react for 12 meters. Wow react for 18 meters. And K react for 65 meters. Timer starts now. Time is up. The answer is heart react 12 meters. How? This can be solved by using the Pythagorean theorem, where C is the length of the longest side of the right triangle and A and B are the legs. The unknown side is A. Hence, B is equal to 5 and C is equal to 13. Substitute the value of B and C and simplify it. The addition property of equality, we get A squared is equal to 144. Get the square root of both sides of the equation and choose the positive root because there is no negative measure of length. The answer is 12. Therefore, 12 meters is the length of the unknown side. The right triangle has length of sides 5, 12, 13. If you can recall, this is called a Pythagorean triple. It will be easy to find the length of an unknown side of right triangle if you notice that the sides will form a Pythagorean triple. Number 2. Given right triangle ACB, the length of the side opposite the 30-degree angle is 7 centimeters. What is the length of the side opposite the right angle? Click like if your answer is 6.06 centimeters. Heart react 7 square root of 2 centimeters. Wow react 14 centimeters. Or K react 7 square root of 3 centimeters. Timer starts now. Time is up. If you answer wow react, then you are correct. Very good. To solve this, you can use the theorem for special right triangles. The given triangle is a 30-60-90 triangle. As you can see, the side opposite the 30-degree angle is the shortest side. The side opposite the right angle is the longest side or hypotenuse. The length of the hypotenuse is twice the shortest side. Hence, we can say that hypotenuse is equal to 2x. Since the length of the shortest side is 7, substitute it for x and simplify it, we get 14. Therefore, the length of side opposite the right angle is 14 centimeters. Number 3. What is the value of x in the given equation? Sine 38 degrees is equal to 16 over x. Round off your answer to the nearest hundredths. Click like react if your answer is 9.85, heart react 10.47, wow react 20.16, care react 25.99. Timer starts now. Time's up. The answer is care react 25.99. Multiply both sides by x, we have x sine 38 degrees is equal to 16. Then, divide both sides by sine 38 degrees. 16 divided by sine 38 degrees is 25.99. Number 4. In the given right triangle, what is the length of x? Round off your answer to the nearest hundredths. Click like react if your answer is 12.29 inches, heart react 18.31 inches, wow react 10.50 inches, or care react 8.60 inches. Timer starts now. Time's up. If you answered care react 8.60 inches, then you are correct. Amazing! The given angle is not a special acute angle. With this, use trigonometric ratio to solve the length of x. Using 35 degrees as the reference angle, x is the opposite side and 15 is the hypotenuse. Now, you have to think of a trigonometric ratio that involves the opposite side and the hypotenuse, and that is the sine ratio. Theta is equal to 35 degrees, opposite side is x, and the hypotenuse is 15. Multiply both sides of the equation by 15, we get x is equal to 15 sine 35 degrees. Evaluate this using your scientific calculator in degree mode and round off to the nearest hundredths, we get 8.60. Thus, the length of x is 8.60 inches. Last number. Which of the following is true for this given figure? Here are the choices. Sine A is equal to h over c. Sine A is equal to c over h. Sine C is equal to a over h. And sine C is equal to h over c. Click the emoji that corresponds to your answer. Timer starts now. Time is up. The answer is like react. Sine A is equal to h over c. The triangle ABC is divided into two right triangles by the altitude h. In this triangle, using angle A as the reference angle, h is the opposite side of angle A, and c is the hypotenuse. Clearly, we will use the sine ratio. Thus, Sine A is equal to H over C. You are doing great, students. As you can notice in our activity, the figure that we use is a triangle. Did you know that triangle is the most stable structure? Triangles are commonly used to offer stability in architectural constructions such as truss, bridges, towers, and skyscrapers because of their capacity to endure immense pressure. Architects and engineers employ various measuring equipment such as tape measure, angle locator, level or inclinometer, and other tools to assure the congruence of triangles in their building's foundation because of its widespread use in architectural projects. And now, let's have another activity regarding triangles. In this, you are going to identify each flashed picture whether it represents a right triangle or not right triangle. Here are the pictures that you need to identify: triangular ruler, hanger, road sign, Burj Khalifa building, window, church, and sailboat. Are you ready? Let's begin. First picture. Identify if the triangle opening of the hanger is right triangle or not. What is your answer? Very good. It is not right triangle. Second picture. Comment your answer below. Great! It is a right triangle. This is a 30-60-90 triangle used in drawing. Third picture. This is one of the front views of the Burj Khalifa. What is your answer? Excellent. This is not right triangle. Fourth picture. If you answered right triangle, then you are correct. It is a 45-45-90 triangle used in drawing. Fifth picture. Comment your answer. Good job. This road sign is not right triangle. Sixth picture. You are doing good, students. This triangular church is not right triangle. Seventh picture. Very good. The sail of the sailboat is a right triangle. And last picture. Bravo! This window is a right triangle. You did great, students. It is easy to identify the pictures between right triangle and not right triangle. A right triangle contains a right angle, while a not right triangle has no right angle. But what do you call a triangle that is not a right triangle? It is called oblique triangle. This triangle contains no right angle. Oblique triangle can be acute triangle or obtuse triangle based on the angles they contain. In an acute triangle, all angles are acute, while an obtuse triangle has one obtuse angle. There is only one obtuse angle in every obtuse triangle, and the remaining two angles of obtuse triangle are acute angles. In our first activity, we could find the missing part of a right triangle by using Pythagorean theorem or trigonometric ratios. How about in finding the missing parts of an oblique triangle? We could use the following methods: law of sines and law of cosines. There are four possible cases of oblique triangle where these laws can be applied. These cases are based on the given length of sides or measure of angles of a given triangle. First, given the two angles in one side. This can be included side or non-included side. In acronym, SAA or ASA. Second, given the two sides and a non-included angle. The acronym for this triangle is SSA. Third, given the two sides and the included angle. The acronym for this is SAS. Fourth, given the three sides, the acronym is SSS. Among the four possible cases of oblique triangles, the law of sines can be used to solve triangle for cases number 1 and number 2. And for number 3 and number 4 can be solved using the law of cosines. Going back to the triangle ABC in our first activity, we can get the ratio of side to the side of its opposite angle, and that is by using angle B as the reference angle. Using this figure, construct an altitude from vertex C to side AB and name it altitude N. In this triangle, using A as the reference angle, the altitude N is the opposite side of angle A, and B is the hypotenuse. With this, we can say that sine A is equal to N over B. Multiply both sides by B, we get B sine A is equal to N. And for this triangle, using angle B as the reference angle, N is the opposite side and A is the hypotenuse. With this, we can say that sine B is equal to N over A, or A sine B is equal to N. So, we have these two equations formed and they are both equal to N. Thus, A sine B is equal to B sine A. Dividing both sides by sine A times sine B, we have this equation formed. These two equations were found using the same figure, thus they are simultaneous equations. With this, we can form this relationship since B over sine B and C over sine C are both equal to A over sine A. And this is a law or formula. This is called the law of sines. Let me discuss this law. Given triangle ABC, where A, B, and C are the sides, and capital letters A, B, and C are the opposite angles of each side respectively. With this, the law states that the ratio of sides of a triangle and their respective sine of opposite angles are equivalent to each other. The ratio of side A to the sine of its opposite angle A is equal to the ratio of side B to the sine of its opposite angle B is equal to the ratio of side C to the sine of its opposite angle C. The term sine is in plural form with S because there are three ratios of sine in a triangle. We can also express the law in this form, but the form that we will use in the examples is the first form. From this given proportion, we can derive these proportions as follows. A over sine A is equal to B over sine B. A over sine A is equal to C over sine C. And B over sine B is equal to C over sine C. This law of sines is one of the methods of solving missing parts of oblique triangle. The other method is the law of cosines, which will be discussed next week. To better understand the use of law of sines, let us answer the following examples. In the given examples, we will round off the final answers to the nearest hundreds, or we will express the final answers containing two decimal places. First, solve for the missing parts of the triangle given A is equal to 12 inches, angle A is equal to 63 degrees, and angle B is equal to 38 degrees. Sketch the figure of the given triangle so that you can have a clear picture of the distribution of the measurements. As shown in the sketch of the triangle, the opposite side of angle A is side A, which measures 12 inches. The triangle described based on the given is an SAA triangle. It is very easy to solve for the measure of angle C. Thus, in solving C, we will use the theorem in which the sum of the interior angles of a triangle is equal to 180 degrees. With this, subtract the sum of the two given angles from 180 degrees. Substitute the measures of each given angle. Simplify it, we get C is equal to 79 degrees. The three angles are complete now. Let us find the other missing parts, the sides B and C. In solving B, use the law of sines. We only need to equate two ratios. But which ratio? One of the ratios must involve a known side and its opposite angle. The other ratio containing the missing part must have known value, either the side or angle. Thus, the proportion is B over sine B is equal to A over sine A. It doesn't matter what ratio will be written on the left or right side of the equation, as long as the order of ratio is correct. That order is the manner of writing the two ratios, whether side over the sine of angle or sine of angle over the side. I will use the ratio side to the sine of opposite angle. Substitute the value of A and the angles A and B. B over sine 38 degrees is equal to 12 over sine 63 degrees. By cross multiplication property, B times sine 63 degrees is equal to 12 times sine 38 degrees. Dividing both sides by sine 63 degrees so that B, which is what we are solving, will be isolated on one side of the equation. Thus, B is equal to 12 times sine 38 degrees over sine 63 degrees. To evaluate this, we must use a scientific calculator. But make sure that your calculator is set to degree mode. If not sure, press the mode or setup button. In its options, select degree or DEG. On top of the display, the three letters DEG, or in some calculator, letter D only must appear. This means that your calculator is in degree mode. If you are finding sine value of angle in degree measure, your calculator must be set to degree mode, or else the value of sine, cosine, or tangent will be wrong. After setting up your calculator in degree mode, you can now type 12 sine 38 divided by sine 63. This is the value. Rounding off to two decimal places, or according to the prescribed number of places, we get 8.29. And that will be the length of side B. One more side to solve, then we are done with this example. In solving C, use law of sines with the ratio containing the unknown side and the ratio containing the known sides and its opposite angle. That is, C over sine C is equal to A over sine A. The length of side A, angle A, and angle C is known. Substitute the value of A and the angle C and A. C over sine 79 degrees is equal to 12 over sine 63 degrees. By cross multiplication property, we get C times sine 63 degrees is equal to 12 times sine 79 degrees. Divide both sides by sine 63 degrees so that the unknown value C is isolated on one side of the equation. Thus, we get C is equal to 12 times sine 79 degrees over sine 63 degrees. Use the scientific calculator to evaluate the value. Again, make sure your calculator is in degree mode. Type 12 sine 79 divided by sine 63. And this is the answer. Round off to two decimal places, we get 13.22. And that is the length of side C. The missing measures of the triangle were solved. We are now done with the first example. Let us answer another one. For example 2, solve for the missing parts of the triangle given C is equal to 42 centimeters, angle A is equal to 38 degrees, angle B is equal to 85 degrees. This shows a sketch of the figure with respect to the given. You can sketch it in any way as long as the label of measurement is correct. According to the given, since the length of side C is given, therefore, it is the opposite side of angle C. Side C is the included side between angle A and angle B. Thus, the triangle described is an ASA triangle. Two angles are given, hence, we can solve for the third angle, which is angle C, by subtracting the sum of the two angles from 180 degrees. Substitute the given measure of angles A and B, simplify it, we get C is equal to 57 degrees. The measure of three angles is complete. Let us now find the lengths of the unknown sides A and B. We can find either A or B. So first, in solving A, use law of sine such that one of the ratios contains the known length of side and sine of its opposite angle, while the other ratio contains a known side and its known opposite angle. Thus, we have A over sine A is equal to C over sine C. We cannot use the ratio B over sine B because side B is unknown. Now, substitute the value of C and the measures of angle A and angle C. A over sine 38 degrees is equal to 42 over sine 57 degrees. By cross multiplication property, we get A times sine 57 degrees is equal to 42 times sine 38 degrees. Divide both sides by sine 57 degrees, we get A is equal to 42 times sine 38 degrees over sine 57 degrees. Using the scientific calculator in degree mode, type 42 sine 38 divided by sine 57. And this is the answer. Round off to two decimal places, it becomes 30.83. Therefore, the length of side A is 30.83 centimeters. The last missing part is side B. In solving for the length of B, use this proportion. B over sine B is equal to C over sine C. You can also equate B over sine B to A over sine A since the length of A and the measure of angle A is known. Substitute the value of C and angles B and C. B over sine 85 degrees is equal to 42 divided by sine 57 degrees. By cross multiplication property, we get B times sine 57 degrees is equal to 42 times sine 85 degrees. Again, it doesn't matter what product is written first. Divide both sides of the equation by sine 57 degrees so that B is isolated on one side of the equation. We get B is equal to 42 times sine 85 degrees over sine 57 degrees. Using the scientific calculator in degree mode, type 42 sine 85 divided by sine 57. And this is the answer. Round it off to two decimal places, we get 49.89. Thus, B is approximately 49.89 centimeters. Now, we are done with this example. The two examples given are the first condition of law of sines, and that is given two angles and one side. Let us now proceed to the second condition, given two sides and non-included angle or SSA. In the SSA triangle, the triangle parts given are two sides and non-included angle. This non-included angle is opposite angle of any given or known side. There are three occurrences of SSA triangle. 1. No such triangle exists. 2. One such triangle exists. And 3. Two such triangle exists. Since there are 3 occurrences, this type of triangle is an ambiguous case of law of signs. Why ambiguous case? Remember that during your 8th grade, the SSS, SAS, ASA, or SAA triangle guarantee that there exists one triangle. However, if the given part of the triangle is in the form SSA, then it is different and makes the triangle unclear, confusing, uncertain, indistinct, or ambiguous. I am going to show you the summary table for the occurrences of ambiguous case of triangle. Since the triangles we are discussing are oblique triangle, therefore it involves 2 types of angles, acute and obtuse. In the SSA triangle, if the given angle is an acute angle, then you cannot easily determine the number of triangles. It can be 0, 1, or 2 triangles. But if the given angle is an obtuse angle, it is easy to determine the number of triangles, either 0 or 1 triangle. For the first type of angle, if given angle A is an acute angle, there are 4 possible lengths of A. To easily understand this, refer to every sketch flashed on the screen. From the first sketch, the length of A is greater than 0 because the length will never be 0, but the length of A is less than the altitude h. How many triangle is formed? 0. Why? Because with the given opening or angle A, side A did not meet the other side represented by the color blue. Hence, there is no closed figure formed. This means the triangle does not exist if A is less than h. Also, we can easily identify if the triangle does not exist in ambiguous case without sketching. Upon solving using the law of signs, if the sine of the angle opposite side B is greater than 1, then there is no triangle exists. You can stop solving, then conclude that there is no triangle exists. For the next sketch, the length of A and H is equal. It is very clear that there is only one triangle exists. The sine of opposite angle of side B is equal to 1, which means that this triangle is a right triangle. If B is equal to 90 degrees, get the sine of 90 using your scientific calculator, it will be equal to 1. The law of sines can also be applied for right triangles. The third sketch shows 2 sides, represented by color pink, with the same length A. The relationship of this side is A is greater than H, but less than B. How is this sketch possible? The angles B sub 1 and B sub 2 are supplement of each other. How? The angle adjacent to B sub 2 is congruent to B sub 1. Thus, this angle is equal to B sub 1. You can find B sub 2 by subtracting B sub 1 from 180 degrees. The sign of supplementary angles is equal. Therefore, there are 2 triangles formed. In this type of ambiguous case, the value of sine of the opposite angle of side B is between 0 and 1. I will show you how to solve this later as we answer some examples. For the fourth sketch, given acute angle, you can see in the sketch that the length of A is greater than the length of B. With this, there is only one triangle formed. The value of sine B is between 0 and 1. And now, if the given angle is an obtuse angle, for the first sketch, it is very clear that the length of A is less than the length of B. Hence, there is no triangle exists. And for the second sketch, the length of A is greater than the length of B. Therefore, find the number of existing triangles if the given angle is obtuse angle. You can only have none or one existing triangle. We can identify number of triangles even if there is no sketch given. Given an acute angle, if sine B is greater than 1, then there is no triangle existing. If sine B is equal to 1, then there is one triangle existing, and that triangle is a right triangle. If sine B is between 0 and 1, then there may be one or two triangles existing. One triangle if the obtuse supplement plus the given acute angle is greater than 180 degrees. And two triangles if the obtuse supplement plus the given acute angle is less than 180 degrees. In a given obtuse angle, if A is greater than 0 but less than or equal to B, then there is no triangle existing. But if A is greater than B, then there is one triangle existing. Number 1, solve for the missing parts of the triangle with A is equal to 3.7 meters, B is equal to 3.5 meters, and angle A is equal to 47 degrees. The length of side A and its opposite angle is given, and the length of side B is given. The triangle described by the given is an SSA triangle. With this, we can solve for the opposite angle of side B, which is angle B. Using the law of sines, the proportion is B over sine B is equal to A over sine A. We cannot use the ratio C over sine C since side C and angle C are unknown. Substitute the given values. We have 3.5 over sine B is equal to 3.7 over sine 47 degrees. Applying cross multiplication property, we get 3.7 sine B is equal to 3.5 sine 47 degrees. Divide both sides by 3.7 and simplify it, we get sine B, which is approximately 0.6918. The value of sine B is between 0 and 1. Hence, there exists one or two triangles. Solve for B and find its supplement to identify if there is one or two triangles existing in the given. Using the scientific calculator in degree mode, find the arcsine of 0.6918. The approximate measure of B is 43.77 degrees. Let us find its supplement. To do this, subtract 43.77 degrees from 180 degrees and we get 136.23 degrees. The sine of 43.77 degrees and sine of 136.23 degrees are the same. So, these are the two possible angles. The sine of supplementary angles is equal. Therefore, if sine B is between 0 and 1, there are two possible angles to exist, which leads to one or two possible triangles existing. Check if 136.23 degree exists as an angle based on the given. Add the obtuse supplement, which is 136.23, to the given angle, which is 47 degrees. The sum is equal to 183.23 degrees. Notice that the sum of the two angles exceeds 180 degrees, which cannot happen because the sum of the three interior angles of a triangle must not exceed 180 degrees. But with this, by using only two angles, the sum exceeds 180 degrees. Thus, 136.23 degrees cannot be an angle of the given triangles. Hence, we can conclude that there is only one triangle exists. Then, the measure of angle B is 43.77 degrees. We now have the measure of two angles and two sides. We only need the measure of angle C and length of side C to complete the missing parts. Two angles are known, thus, we can solve for the measure of angle C. In solving for C, get the sum of A and B and subtract it from 180 degrees. Substitute the measure of the two angles and simplify it, we get 89.23 degrees. Therefore, angle C measures 89.23 degrees. For the last missing part, to solve side C, use law of sines. The proportion is C over sine C is equal to A over sine A. Substitute the known values, we have C over sine 89.23 degrees is equal to 3.7 over sine 47 degrees. By cross multiplication property, the result is C sine 47 degrees is equal to 3.7 sine 89.23 degrees. Then divided by sine 47 degrees to isolate C, we get this equation. C is equal to 3.7 sine 89.23 degrees over sine 47 degrees. Solve it using your scientific calculator. In degree mode, you will get approximately 5.06 meters. Thus, the length of side C is 5.06 meters. Since the measure of all angles and length of all sides are known, then we are done. Number 2. Solve for the missing parts of the triangle with A is equal to 11 feet, B is equal to 18 feet, and A is equal to 26 degrees. Given is the length of A and the measure of its opposite angle as well as the length of side B. The triangle described by the given is an SSA triangle. With this, we can solve for the measure of angle opposite side B, which is angle B. In solving for B, use law of sines. The proportion is B over sine B is equal to A over sine A. Substitute the known values, we have 18 over sine B is equal to 11 over sine 26 degrees. By using cross multiplication property, we have 11 times sine B is equal to 18 times sine 26 degrees. Then, divided by 11, the result is sine B is equal to 18 times sine 26 degrees over 11. Simplify it, we get sine B is approximately 0.7173. Since sine B is between 0 and 1, then there are two angles possible and there exist one or two triangles. To find the first angle, get the arcsine of 0.7173 using the scientific calculator in degree mode. We get the approximate measure of angle B, which is 45.83 degrees. For its obtuse supplement, 180 degrees minus 45.83 degrees, and this is equal to 134.17 degrees. 45.83 degrees and 134.17 degrees are the two possible angles. Verify if the obtuse supplement 134.17 degrees can be an angle of the triangle given by adding 134.17 degrees and the given angle 26 degrees. We get 160.17 degrees. Since the sum is less than 180 degrees, then there are two triangles exist. The first angle is the acute angle, 45.83 degrees, and the second angle is the obtuse supplement of acute angle, which is 134.17 degrees. To see a clear picture of how it will look like, refer to this figure. Where angle A is equal to 26 degrees, side B is 18 feet, and side A is 11 feet. And the measure of angle B is 45.83 degrees. From vertex C, draw a segment to side AB where the length is equal to 11 feet and label the point intersected as B prime. In this illustration, angle CB prime B is also 45.83 degrees. This is like a triangle formed by the altitude that mirroring on the other side. For the obtuse angle, it is equal to 134.17 degrees, which is the obtuse supplement. Hence, these are the two triangles. In the obtuse triangle and in the acute triangle, the side opposite angle C is C. There are also two measures of angle C. In the obtuse triangle, let us denote this as angle C prime, and in acute triangle, let us denote this as angle C. Let us continue solving for the other missing parts. In solving angle C in the acute triangle, add angles A and B and subtract it from 180 degrees. Substitute the value of each angle and simplify it. The answer is 108.17 degrees. Hence, angle C is equal to 108.17 degrees. Solving for angle C prime, get the sum of angles A and B prime. Then, subtract it from 180 degrees. Substitute the values of the two angles and simplify it. We get 19.83 degrees. Hence, angle C prime is equal to 19.83 degrees. And now, solving for the sides C and C prime, let us start with solving C. Using the law of sines as shown, substitute known values, then apply cross multiplication property, divide both sides by sine 26 degrees, we will have
C is equal to 11 sine 108.17 degrees over sine 26 degrees.
Using the scientific calculator in degree mode, the approximate value is 23.84. Thus, the length of C is 23.84 feet. Next, for the last missing part, solving the length of C prime. Again, use law of sines, substitute known values, then apply cross multiplication property, divide both sides by sine 26 degrees. Using the scientific calculator, the approximate value is 8.51. Thus, the length of side C prime is 8.51 feet. We are done with the second example. Let us now proceed to the last example. Number 3. Find angle B in a triangle with angle A is equal to 34 degrees, A is equal to 1.2 centimeters, and B is equal to 2.3 centimeters. To solve B, use the law of sines involving the ratio with the unknown angle B. That is, B over sine B is equal to A over sine A. Substitute the needed values we have. 2.3 over sine B is equal to 1.2 over sine 34 degrees. By cross multiplication property and dividing it both sides by 1.2, we get sine B is equal to 2.3 times sine 34 degrees over 1.2. Find the answer using the scientific calculator. We get sine B is approximately 1.0718. Referring to the table I gave earlier to describe sine B, since sine B is equal to 1.0718 and sine B is greater than 1, therefore, we can stop here and conclude that there is no triangle existing. And again, that is the last example. At this point, let us test your understanding in solving the missing parts of an oblique triangle by having this activity entitled, Let's Solve This Together. We will answer 5 questions to complete the parts of the given triangle. You will be given 10 seconds to choose the letter of the correct answer in every item. Number 1. Which of the following is the correct way to solve for angle A? Is it A, 29 over sine 50 degrees is equal to 37 over sine A? Or B, 29 over sine 50 degrees is equal to A over sine 37 degrees. 10 seconds, go! Time's up. If your answer is A, 29 over sine 50 degrees is equal to 37 over sine A, then you are correct. Very good. Number 2. What is the measure of angle A? Is it A, 22.78 degrees, or B, 77.79 degrees? Timer starts now. Use your answer in item 1 to solve for angle A. Time's up. If you answered B, 77.79 degrees, then you are correct. Amazing. Next, what is the measure of angle B? Is it A, 52.21 degrees, or B, 152.21 degrees? You have 10 seconds. Go. Time's up. The correct answer is 52.21 degrees. Subtract the sum of angle A and angle C from 180 degrees. Number 4. Which of the following is the correct way to solve for the length of side B? Is it A, 29 over sine 50 degrees is equal to B over sine 52.21 degrees? Or B, 29 over sine 50 degrees is equal to B over sine 77.79 degrees? Timer starts now. Time's up. If your answer is A, 29 over sine 50 degrees is equal to B over sine 52.21 degrees, then you are correct. Great! For the last number, what is the length of side B? Is it A, 28.11 centimeters, or B, 29.92 centimeters? You have 10 seconds to comment your answer. Go! Time's up. If you answered B, 29.92 centimeters, then you are correct. Perfect. We have completed the parts of the given triangle. Wow! It has been a long discussion today, but it is an amazing learning session. I hope you learned something essential today. For the generalization, let us sum up everything we discussed today. Oblique triangle is a triangle that contains no right angle. Oblique triangles can be acute or obtuse triangle. The law of sine states that the ratio of the length of a side of a triangle to the side of the angle opposite that side is the same for all sides and angles in the given triangle. In any triangle ABC, A over sine A is equal to B over sine B is equal to C over sine C, or sine A over A is equal to sine B over B is equal to sine C over C. The two possible cases of oblique triangle that can be solved using law of sines are given two angles in one side, or the ASA triangle, given two sides and non-included angle, or the SSA triangle. The SSA triangle has three occurrences. 1. No such triangle exists. 2. One such triangle exists. And 3. Two such triangle exist. That is why this triangle is called the ambiguous case of law of signs. For the frequently asked question, can we still use law of signs if we are given two sides and an included angle of a triangle, or if we are given three sides of a triangle? No, we cannot use law of signs because we cannot set up any proportions where enough information is known. In these two cases, we must use the law of cosines. For other questions, you may ask your class discussion teacher and he or she will discuss it in your follow-up discussion. For your home learning task, answer keep trying A and B numbers 1 and 3 only. Thank you for attending and actively participating on our today's lesson. I hope that you learned a lot from the discussion. Always stay safe, everyone. Have fun learning and God bless you all. Bye!